Here in the biggest important part of our physics, that is Doppler effect, which understand that how sound propagates or light propagates and change the apparent frequency in a system. Doppler give us the idea also, as you know, the red shift, blue shift, that is the approaching and giving away from a particular reference frame of a star. But in class of sound, Doppler gives certain interesting law, and the law is that how when a source producing certain amount of frequency of sound and propagating through the medium and come to an observer or a listener, how the frequency change if their positional vector of velocity change. Before coming to the law, first we have to know where we will apply this law and where not. Interestingly, those questions you will get in your IIT paper, especially, there will be the non-applicable part of Doppler effect maybe, or the complexity of the applications of this Doppler effect. When you come to the propagation nature, a source can produce a frequency of sound f naught propagating through a medium of uniform density with speed v and reaching to a listener to the point B. Definitely, if they are not changing their position from each other relatively, then maybe the frequency will lose certain amount of energy and come to this point, but this is not apparent change. Apparent change will take place if the listener comes towards the source, or the source comes towards the listener, or both comes towards each other, or both move away from each other, or a reflector takes place in between them to get the different position of locations of sounds, which is called locopositions. So in this interesting case, we will discuss what Doppler effect have to fight. First thing, since sound energy is propagating and losing certain amount of energy during propagation, so definitely the nature of the waves should be progressive, longitudinal in nature. From this part, we have to understanding as the beginning of this chapter that energy must be lost during this propagation from a point to other points. And second point is that the dimension of the propagating velocity and change of pressure between crest and tops must be in same directions. So that's why the Doppler effect of sound you can apply when the observer or listener with respect to the source are in the same plane. Interestingly, you get the question from this side also. Second part, whatever you understand, in these propagating waves, the speed of the waves must be very, very greater than the relative speed between the speed of source and speed of listener. Implies the speed of listener and speed of source and their relative velocity cannot be comparable to the speed of sound. As we know, the speed of sound is 332 meters per second, and the speed of listener may be moving with 72 kilometers per hour. That means you are getting near about 20 kilometers per second, 20 meters per second. So that's why in this particular situation, you will say that the relative velocity must be very less. And third point, this relative velocity cannot be zero. That means between the source and listener, the relative velocity must be there. If there is no relative velocity, such as a man is horning in his car and other man is moving with him on the other car and both are moving with same velocity, definitely source is there, listener is there, but relative velocity is zero, therefore Doppler effect is not applied there. And the other most important point is that in these propagating waves, wave must have a spherical wavefront. So that means the wave front of this wave must be spherical in nature. If the wave is spherical in nature and propagating in spherical wave front, then only the Doppler effect is applicable. But if this spherical wave front, due to the velocity of the source or due to the density changing in the medium as a heterogeneous, it comes like as a conical wave front, then the Doppler apparent frequency applicable is not. So sometime if the wave change is spherical wave front to conical waves, the Doppler effect again is not applied. So before coming to the equation and formulas, we must have to know where we should apply, where we should not apply. And you go through your questions in last 5-6 years of IIT and PMT, you will see questions are not coming on the position of numericals from this formula. Question is coming from the non-applicable and applicable part of it with respect to the propagating wave nature. Since the wave is progressive longitudinal, therefore the equation of the wave propagation will be A sine omega t plus minus kx, and medium density taking as a constant, therefore propagation constant, propagating wave velocity cannot be changed in this situation, they will take as a constant. So in such a situation, we are not considering the wavelength function because k as a constant means 2 pi by lambda as a constant. That's why in the Doppler effect of sound we discuss the change of frequency, although in the Doppler effect of light we discuss the change of wavelength, because at that instant k function taken as a propagation velocities with wave velocity and with certain phase with respect to the transmission is changed. We will discuss if it is in your syllabus, but since sound is in your syllabus, definitely we are going to the sound part of it. Now what is the equation of Doppler effect? We understand that Doppler effect is applicable for the propagating waves in a relative velocity as a longitudinal propagations. Equation, if we consider the speed of source, if the source as a train moving towards a stationary observer or listener at a platform, the speed of source is taken as Vs, speed of sound is taken as V, speed of listener is taken as Vo, observer velocity, and if we consider that winds is blowing from source to listener, then Doppler gives a very simple equation of speed of apparent change, and that is this equation. It is V apparent, definitely relative is there, therefore F apparent is F naught V plus minus V naught plus minus VW upon V minus plus Vs plus minus VW. As we know, V speed of sound is taken as a constant for a particular conditions. V naught is the speed of listener, Bw is speed of wind, Vs is the speed of source. If not consider the wind speed, because in IIT syllabus that is not given to you, if we not consider that part, the equation become apparent change is F naught V plus minus V naught V minus plus Vs. Now what is this sign convention? We must have to apply the conventional effect of the speed of source to the speed of listener. Reference is the speed of source. Now if we see the source is approaching to the listener, definitely listener will get more frequency. So if the source is moving towards the listener, the denominator will be taken as negative, right? But if the source is moving away from the listener, denominator will be taken as positive because he will get less frequency. So for the speed of source, minus sign will be taken if it is moving towards to listener, plus sign will be taken if it is moving away from listener. Please understand all these things together, because in to give the result of a question or to answer a proper conceptual question, analysis must be in your mind and it will be click within a minute when you read out the question for the any explanations. For the source, it's no. Now for the listener, as you understanding, if the listener moving towards the source, just there is a siren horning in a particular factory and a man is moving towards the factory, so definitely he will get more frequency. So when a observer or listener is moving towards the source, it will be plus in the numerator and it will be minus if it is moving away from the source. So for the observer, we will say that plus sign will be taken if it is moving towards to source, and it is minus will be taken if it is moving away from source. From all these four conventional facts, we will get different types of laws, and I will discuss different aspects, what types of question usually used to get, but what is necessary from this equation is the percentage change of frequency or apparent change in the bits, because this chapter is completely understanding of bits. Do you know what is bits? I will discuss after the summarization of this chapter how the two superposition waves give you interference as we understand in the open close or confine, how they make beats, that is we are discussing in this Doppler effect, and how they make standing waves such as strings when its end is closed or maybe one end is open. So briefing will come after completing all this. Coming to the point, other cases for the Doppler effect: if source is stationary, observer is moving; if observer is stationary, source is moving. Both are moving away, or the relative velocity with respect to different plane position or positional vector of the listener or the source.